James Webb, an eye that broke the boundary between past and present and revealed the universe as it has never been seen before. Clouds parted, newborn stars shone amid the dust. Galaxies spiraled, and the structure of the universe revealed itself. In the heart of every image, the sound of the birth and death of stars echoes. And in the distances, galaxies shine that were born only a few 100 million after the Big Bang. Webb not only looked into the depths of space, but into the depths of time, to show that the universe is more alive and mysterious than we thought. And perhaps these gazes will change our view of the cosmos forever.
Welcome to the Astrion channel. Today we're going to have an exciting journey together into the heart of the cosmos with the help of the James Webb Telescope, which has truly transformed everything. This telescope has acted like a magical eye and shown us things we couldn't even imagine before. I want to tell you about these discoveries, but not in the usual order. Instead, we'll start with things closer to home, our own solar system, and gradually go toward the depths of the cosmos, where the wonders get bigger and crazier. It's like we're peeling back the layers of the cosmos, and with each layer we go further, a bigger secret is revealed. Let's start with something that's happening right in our own backyard. James Webb hasn't just looked at distant places, it's also paid special attention to our solar system and shown that even here, the cosmos is full of hidden wonders. One of the most interesting discoveries is the massive water plumes on icy moons like Enceladus, Saturn's moon. Webb has mapped a water plume erupting from Enceladus's south pole that's over 6,000 miles long. That's 20 times the size of the moon itself. This water spins around Saturn like a torus, a donut-shaped ring, and even some of it falls onto Saturn itself. That means Saturn is getting water from its moon. Webb has even shown other things like Uranus's rings, Neptune's auroras, Titan's clouds with methane rain, Jupiter's winds, and Europa's ices in detail. These discoveries help us understand how the subsurface oceans on these moons work, and maybe even have potential for life. And even more interesting, Webb has measured dangerous asteroids, like asteroid 2024 YR4, which is the size of a 15-story building. And now we know it's no longer a threat. Webb even participated in NASA's DART mission, and showed what explosion of material happens when a spacecraft hits asteroid Didymos. Compositions that show these asteroids are made of ordinary, dangerous materials. This work by Webb is like a cosmic guardian, helping us defend Earth. Now that we've seen how alive the cosmos is in our own system, let's take a step back and see how these structures form in our nearby galaxies. One of the fascinating discoveries is the stunning details of spiral structures in galaxies like NGC 628 or the Phantom Galaxy. With its infrared vision, Webb shows warm dust in red, glowing gas knots in orange-yellow, giant black bubbles created by hot stars, and the dust-free core with old blue stars. These images show that galaxies are like living cosmic cities. Stars are born in dust, stellar winds and explosions create holes, and everything is recycling.
Webb has even shown that these structures formed earlier than expected, even in galaxies 1.5 billion years after the Big Bang. Fully spiral galaxies like today existed. This means gravity and dark matter acted much faster. These discoveries help us understand how our own Milky Way galaxy was built. Now that we've seen the structures, let's go to where these structures start.
Webb, with its power to push aside dust veils, has taken us into the heart of dark cosmic clouds, where stars are forming. For example, the Carina Nebula and the Pillars of Creation, which were blurry in Hubble's photos, are now vivid and detailed with Webb. We can see how gas and dust clouds collapse under gravity and create newborn stars. Webb has shown that this process happens much faster than expected, even in the early universe. Stars formed at unimaginable speeds. For instance, early galaxies were like giant star-forming balls, with explosive star formation rates that models didn't predict. This means the initial conditions of the cosmos, like lack of dust or different physics, made stars faster. Around many of these newly born stars, Webb has found rings of gas and dust called protoplanetary disks. These disks are like planet-building workshops. Tiny particles stick together, become pebbles, then larger masses, and finally, planets. Webb has shown that these disks last longer than expected, 20 to 30 million years, not just a few million. For example, around the star HL Tauri, gaps in the disk have been seen that indicate young planets clearing their paths. It's like we're directly watching the birth of planets. And even more interesting, Webb has found complex chemical compounds, like organic molecules, that are the building blocks of life. This means the processes leading to life may have started much earlier and more widespread. And it even showed how strange the shapes of early galaxies are. These discoveries tell us the universe is full of these workshops. Webb has found hundreds of these objects that are neither fully stars nor planets. Brown dwarfs form from gas like stars, but aren't hot enough to burn hydrogen. Rogue planets are like regular planets, but have been ejected from their systems and now wander. Webb has found things as small as a few times Jupiter's mass, like in the Flame Nebula, that scientists don't know how they formed. Are they from protoplanetary disks, or like stars? Even more interesting, Webb has found planets that have even survived the death of their star. Around white dwarf stars, the hot cores left from dead stars, planets have been seen that survived the red giant phase and are still orbiting. This means planets are tougher than we imagined. Webb, with its sensitive spectroscopy, has examined the atmospheres of exoplanets and found crazy things. For example, in gas giants, compounds like hydrogen sulfide, ammonia, carbon dioxide, methane, and sulfur dioxide have been seen. Even silica snow on WASP-17b, or temperature and cloud differences between permanent morning and evening on WASP-39b. On rocky planets like 55 Cancri e, a lava world 40 light-years away, a thin atmosphere of carbon monoxide or carbon dioxide has been found coming from its boiling surface. These discoveries not only show planetary weather, but help better understand their formation and evolution. And this takes us to the bigger question: do these atmospheres show signs of life? When Webb looks at atmospheres, it's searching for biosignatures, molecules like oxygen, ozone, or methane and carbon dioxide combinations that, on Earth, are produced by life. Webb has the precision for the first time to check these molecule ratios. For example, in K2-18b, water, methane, and carbon dioxide have been found, and even the possibility of dimethyl sulfide, DMS, which on Earth is only produced by living things. Webb has shown complex chemistry started much earlier, like nitrogen in galaxy JADES GS-Z14-0, just 300 million years after the Big Bang. This means the chemistry needed for life existed faster than expected. But Webb has also found a new mystery: little red dots. Small and compact galaxies about 600 million years after the Big Bang. These are red and bright, perhaps from dense stars or gas falling into black holes. But stranger still, they disappeared less than 1 billion years later. Where did they go? Webb is searching for them to figure out what these cosmic jewels became. This discovery relates to black hole growth and galaxy evolution, and takes us to much older galaxies. JADES GS-Z14-0 with redshift 14.32, just 290 million years after the Big Bang, with oxygen that shouldn't be there then. Or JADES GS-Z13-1 with Lyman alpha emission that passed through hydrogen fog, meaning ionization started earlier. This means the universe built structure faster, and galaxies were like complete cosmic cities, not foggy masses. Webb has even shown that galaxies in the early universe had strange shapes. And this is a big challenge for models. But at the heart of many of these galaxies, Webb has found black holes with masses millions of times the Sun, just a few hundred million years after the Big Bang, like one with 9 million solar masses at 570 million years. These either grew fast or were big from the start, perhaps from direct gas collapse. These black holes were the engines of galaxies, and by swallowing matter, created quasars that are brighter than an entire galaxy. Webb has found early quasars showing heavy elements like carbon and oxygen, meaning star formation was rapid. These cosmic lighthouses help examine the initial gas. Webb has reached the largest scale, the cosmic web, filaments billions of light years long that formed earlier than expected, like a 3 million light-year filament just 830 million years after the Big Bang. This is held by dark matter, but Webb has even raised MOND as an alternative to dark matter. And the Hubble tension? Webb, with pulsating stars and triple-lensed supernovae, has shown the universe's expansion is faster, at 70 to 76 kilometers per second per megaparsec, not 67. This means our physics needs rewriting. Perhaps dark energy is different. Each discovery from James Webb is a window to the hidden secrets of the universe, and shows that the cosmos is more complex, faster, and more mysterious than any of our imaginings.